Okay, we are going to look through 2.6. We're going to do 1 through 15 for the rest of Monday's class. So 2.6, numbers 1 through 15. Okay, 2.6 is combinations and compositions of functions. So we're still dealing with functions. All this chapter we will be. We're going to combine them. We're going to compose them. Those are two different things. It's not important that you know the difference between them. When you're dealing with any function or any equation, there are two big no-nos. The first one is that you can't have the equation can't have a 0 in the denominator. We can't divide by 0 in math class, so we won't. So we're going to have to make sure that we don't have a 0 in the denominator. The other thing that we can't have is the equation can't have a negative number under a radical. Okay, those are our two no-nos, and we're going to spend the next 1, 2, 3, 4, 5, 6, 7, 8, 9 problems making sure that we don't have a 0 in the denominator or a negative number under a radical. So the instructions for these next, whatever I said, 9 problems, 10 problems it looks like. Yeah, 10. They're going to tell you in interval notation, describe the domain. What are you allowed to put in for x? What will this equation use for x? What will this function use for x? So let's look at our first one. Y equals 5x plus 2. Is there a denominator here? No, there's no denominator, so we don't have to worry about violating number 1. Is there a radical that might have a negative number in it in this equation? There is not. So there's no restriction on our domain. The domain is going to be negative infinity to positive infinity. It doesn't have either of our problem areas. Those are the only two things we're worried about. Number 2, let's look at g of x equals 7 over x plus 6. Okay. Number 1, we can't have a 0 in the denominator. Do we even have a denominator here? Yeah, we do. So we're going to have to protect for that. Do we have a radical? No. So we don't have to worry about number 2, but we do have to worry about not allowing this denominator to become 0. So let's set it up. X plus 6 cannot be 0. That's the only requirement for our function, is that our x, when we add 6 to it, cannot equal 0. Let's solve for this. Move the 6 to the other side. So x cannot equal negative 6. That's our rule. That's what we have to make sure of here. Because if we put a negative 6 in there, negative 6 plus 6 is a 0 in the denominator. 7 divided by 0. I mean, try it on your calculator. It says domain error. It says you made a boo-boo. You cannot allow that to become you cannot allow 0 in the denominator. So we have to put this in interval notation. I'm kind of a fan of making a number line so I can see what I'm talking about. Everything back here less than negative 6 is good. Everything up here bigger than negative 6 is good. Just not negative 6. So I'll use parentheses there to indicate that. And then I just read right off of that. So in interval notation, the domain is negative infinity to negative 6, parenthesis, union negative 6, close the parenthesis. So like if you're swimming from left to right, you get in the pool at negative infinity, you swim till you get negative 6, you have to jump out of the pool, jump back in at negative 6, and keep swimming to infinity. That's what that says in interval notation. These say the same things. X cannot be negative 6. That's what this says. X can be everything else but not negative 6. look at number 3. F of x equals 1 over x plus 1 over x minus 5. Again, we have the potential of violating the first rule where we can't have a 0 in the denominator. We're not going to have to worry about radical, a negative number under our radical, because we don't have any radicals here. But there are 2 different situations we have to worry about. That denominator cannot be 0, so x cannot equal 0. That's one of our restrictions. The other one, that is x minus 5, cannot equal 0. So you can set these denominators not equal to 0 to watch out for what you got. There's one of our rules, x cannot be 0. Move the 5 over. X can also not be a positive 5. So on a number line, let's find our no-nos. We've got a no-no at 0 and we've got a no-no at 5. Everything else is okay. Everything else is allowable here, but not 0 because it'll blow up this half of the fraction, or this half of the problem, and not 5 because it'll blow up this one. So all of this is good stuff. Everything between 0 and 5 is good, and everything bigger than 5 is good, but not 0 and not 5. So be a swimmer, start in the negative direction. Negative infinity, you can swim to 0. You can't touch 0. You got to get out of the pool, get back in the pool for this little piece from 0 to 5, and then jump out of the pool again and swim on from 5 to infinity. So this domain equals this stuff. That means you can't have 0, you can't have 5, but everything else will work in this equation, in this function. That's what this says. 0 can't be x, 5 can't be x. Let's look at number 4. H of x equals 4x plus 7. It's a plus sign there. 4x plus 7. Okay. Our only no-nos are denominators that become 0, radicals that have a negative number in them. So which problem do we have here? We don't have a denominator, so we don't have any worry about making a denominator be 0. We don't have a radical, so our domain has no restrictions. We can plug in anything in the world we want to for x. It's not going to blow up on us. Number 5. F of x equals 3 over x minus 2. This is very much like number 2 in that we have a simple denominator, and we've got to make sure that we don't make it become 0. The denominator cannot become 0. If you feel like it, pause right now and see if you can come up with the domain in interval notation for this equation. If not, let's just keep plugging away. So we have to make sure that this piece right here, x minus 2, does not equal 0. Move the 2 over. X cannot equal 2. So I need to say that in interval notation. I'm a fan of writing it on the number line. Everything back there is good. Everything up there is good, just not 2. Stay away from 2. Get in on the left-hand side. That starts at negative infinity. You swim, swim, swim to 2. Get out of the pool at 2. Jump back in on the other side of 2 and swim to infinity. Put that union symbol between them. So the domain here equals negative infinity to 2, but not touching 2. And then get on the other side of 2, 2.000 infinitely 1, and get out at infinity. Number 6, f of x equals x minus 4 over x squared minus 4x minus 5. Okay, well, we've got a quadratic down here in the denominator. So remember, our 2 rules are that we have to prevent the denominator from becoming 0. We've got a denominator. Let's figure that out in a second. And making sure the radical doesn't have a negative number in it. We haven't seen that yet. So let's just worry on this piece, x squared minus 4x minus 5 not being 0. Let's factor it. X and x. Signs need to be different. What makes 5, what multiplies to give you 5, that subtracts, whose difference is 4, of course that's going to be 1 and 5. And then What will multiply to give you -5? Nah, that's not how Chloe was doing it. I've kind of forgotten. Oh yeah, what will give you -4? Because that's a way I don't do it. I do it a different way, and I like her way better, and it may be many of your ways. What will give you -4 when you add them? A -5 and a +1. So put the numbers that way. +1 goes here, -5 goes there, and then we've got that -5. Outside -5, inside +1, we've got a -4x. Okay, keep going. X plus 1 cannot equal 0. X minus 5 cannot equal 0. So x cannot equal -1, and x cannot equal 5. Let me get myself a little number line here. All that mess is good. Anything between them is good. All that mess out to the right is good. Not -1, not +5. That's what it says there. So the domain equals, let's start in the negative infinity. We can swim right up to -1. Then we're going to have to get out of the pool, get back in right there on the other side of -1, swim to 5, get out, get back in at 5, and swim to infinity. So all of that, those three parts. One part, the little numbers. Second part, the big numbers. Third part, the numbers between them. Number 7. G of x, and this doesn't matter, I'm just, picking letters. F, G, and H are usually letters used to describe functions. 1 over x squared plus 8 plus 1 over x squared minus 16. There's the problem right there. Okay, we got two no-nos. We can't have a denominator equal to 0, and we can't have a radical with a negative number on it. We don't have any radicals here. We only have denominators. So I need to make sure of two things. One, that x squared plus 8 does not equal 0. And the other, that x squared minus 16 does not equal 0. Let's do this one first, a little bit easier. That's the difference of two perfect squares. So x and x, the signs need to be different. What two numbers multiply to give you 16? 4 and 4. And there we go. So x plus 4 cannot equal 0. X minus 4 cannot equal 0. Send the 4's over. X cannot equal -4, and x cannot equal 4. Now let's mess with this one. Again, we're solving it, so send the 8 to the other side. X squared cannot equal -8. We're done. X squared can never equal a negative number. Any number you put in here, you're going to end up with, when you square it, you're going to end up with a positive number. If your instinct was to take the square root of both sides, good for you. If we do that, squaring and unsquaring cancel each other out, then this is the square root of -8. The negative comes out as an I. That's I on the square root of 8. That can still be simplified, but that doesn't matter. This I tells you this is an imaginary number. So x cannot equal an imaginary number. No worries, that's not on our number line. So the square root of a negative number, remember that's one of our problems anyway. We created that, no big deal. But what happens here, remember originally we had x squared cannot equal a negative number. No problem there. There is no real number that when you square it, you're going to get a negative number. It's even like -3 times -3 is going to give you a +9. You can't get this done. So no worries there. No restrictions from this part of our function. That's not going to create a problem for us. This part is, we cannot have we cannot put in an x that is a -4 or a +4. Again, if you feel like pausing this right now and seeing what you can do on it. So the domain equals -infinity takes you right up to -4's door. Then the span between -4 and 4. And then finally this big span from 4 to infinity. Okay, that's number 7. Let's look at the rest of these little guys. Looks like we got about 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know. Can't count and think at the same time. Okay, 3 more, I can tell you that. So 10 of them total. Number 8, these last 3 deal with radical problems. H of x equals the square root of x plus 15. Remember, we got 2 rules, we got problems that we got to worry about. Can't have a 0 in the denominator. There is no denominator here, so we don't have to worry about our first big no-no for the domain. We do have to worry that our equation cannot have a negative number under the radical because we have a radical in this problem. So x plus 15 cannot sink below 0. So the way we're going to write that when we have a radical is take out the guts, x plus 15 must be greater than or equal to 0. That's our rule. Whatever is underneath the radical can be equal to 0. Like if we put a negative 15 in there, negative 15 plus 15, that's 0, and we've got a square root for 0. But we don't have a square root for a bigger number than that. So this is the rule. You've got to be bigger than or equal to 0. All the time we'll use that phrasing when we've got a radical. Okay, finish this problem off. X has got to be greater than or equal to negative 15. Now you have to write that in interval notation. There's negative 15. You don't need a number line if you don't need a number line. I need a number line, so I'm going to always write a number line. I know that my answer needs to be greater than or equal to negative 15. That arrow tells me which way to shade. It's pointing me to the right, so I'm going to shade to the right, and I'm allowed to include negative 15. Because if we do include it, negative 15 plus 15 is 0. Square root of 0 is still a cool number. But over here, negative 16, that gives you negative 1 under here, and you cannot take the square root and stay in the real numbers. Take the square root of a negative number. So we need this in interval notation. Nothing back here, nothing back here. We haven't started using, oh, right there we start using. Pull it straight off of the number line. Negative 15 is where it starts. Use that symbol. It goes to infinity. Number 9, f of x equals the square root of 3x minus 12. First, do we have a denominator? No, we don't. Second, do we have a radical? Yeah, we do. So we have to make sure that this stays at 0 or above. It has to be non-negative. So 3x minus 12 has to stay greater than or equal to 0. Let's solve for x. So move the 12 over. Divide by 3. And there's our answer, more or less in set notation. We need to put it in interval notation. So I'm going to use a number line. My arrow is pointing me to the right, so I know that all the numbers to the right of 4 are good, and I'm allowed to include 4. Because if I put it in there, 3 times 4 is 12, 12 minus 12 is 0, and I can take the square root of 0. In interval notation, that's 4 on out to infinity with a bracket at 4. And then our last one, this whole, so far, these first 10 problems, although you'll have other problems first, but you'll have a whole mess of problems where you're asked in interval notation, describe the domain. And there are only 2 areas to watch out for, the denominator being 0 and a negative number under the radical. So this is the last of those. G of x equals the square root of x minus 6 plus the square root of x plus 7. Okay, it's just a combo of these, and there's a trick to it. Let's look at them. You know this piece has to be non-negative. So x minus 6 is going to have to be greater than or equal to 0, and x plus 7 is going to have to be greater than or equal to 0 also. We can't have this being a negative number. We can't have this being a negative number. So move the numbers over, and we get x is greater than or equal to 6. X is greater than or equal to negative 7. Let's look at that on a number line. This one, let's say the 6 is here, and the negative 7 is there. This one says x has got to be greater than or equal to 6. I'm going to do this in orange. So it's going to look like that. The other one, greater than or equal to -7, looks like that. Now, if we were only doing this problem, 6 and bigger would be good. If we were only doing this problem, -7 and to the right would be good. But we're doing both at the same time. So you have to make sure that every number you choose will work here and will work there also. So what happens if we put in -7? All is good here, but all ain't good there. -7 minus 6, that's the square root of -13, and we've got a negative number under there. So these that are by themselves will not work over here. Only 6 and to the right will work for both of them. -5 won't work, 0 won't work, still a problem here. So we're going to have to grab where there's overlap, where our number line works for both this problem and for that problem also. So the domain here will be 6 and out to infinity. It can only be the amount, the portion of numbers here on the number line that will work in both cases. These numbers out here are not covered with the orange. You're looking for where there's orange and purple. So from 6 to the right. Okay, let's do a couple more problems and then we'll be through with number 15 on your MyMathLab. The next thing we want to look at, the instructions will say find f plus g, find f minus g, find f times g, and find f divided by g, and then what is the domain for each one of them? Okay, we're going to hold off on the domain for each one of them until we finish these. Let's first do each of these four. Well, we need an f. Here's f of x equals 5x minus 4, and g of x equals x plus 8. Okay, let's first do f plus g. F plus g is going to be the f function, that's 5x minus 4, plus, let me emphasize that, plus the g function, and the g function is x plus 8. Let's combine like terms here. We've got a 5x and an x, so that gives us 6x. Got a -4 and a positive 8. That gives us 6x plus 4. Okay, that's f plus g. Let's go do f minus g next. So grab the f function, that's 5x minus 4, and then minus, this is subtracting these, minus the g function. The g function is x plus 8. Ooh, that's two different terms. So we're going to be required to put both of them in parentheses because we're doing one action to two different terms, and we'll now need to distribute them. You'll muck this up if you don't notice that. So the minus is super picky like that. So that gives us 5x minus 4 minus x, and then a negative times a positive, that's a -8. Watch out for that. You've got to distribute a minus sign over both of the terms. It's not a minus x and then just a plus 8. It's minusing all of the g function. And now we'll combine like terms. 5x minus x is 4x. -4 minus 8 is -12. Let's do f times g. So let's grab the f function. That's 5x minus, sorry, right there, 5x minus 4. And we're going to multiply it times the g function. Well, that's two terms, and we're going to multiply it times two terms. And there you go. You've got a FOIL problem. So 5x squared, outside is 40x, inside is -4x, last is -32. Let's combine those insides. And there's our f times g answer. Let's do f divided by g. So the f function is 5x minus 4. The g function is x plus 8. And there's nothing we can do with that. There's no GCF that we can factor out and divide through. So there's the answer. Okay, remember we had to also do domain for these. And remember the two things you have to worry about are, grab them for you again, the two things you have to worry about is equations can't have zeros in the denominator, and they can't have a negative number under a radical. So on f plus g, we don't have any denominators, we don't have any radicals. So the domain here is just negative infinity to positive infinity for this f plus g. F minus g right there, or even right here, anywhere along the line, we didn't have a denominator, we didn't have a radical. So the domain for the subtraction one is negative infinity to positive infinity. The domain for f times g, no denominator, no radical. So the domain is no restrictions, negative infinity to positive infinity. Here's the first one when we divided that we've got a variable in the denominator. We got something to worry about. Just like we did on 1 through 7, x plus 8 cannot equal 0. That denominator cannot equal 0. We don't care what's going on in the numerator. That can be 0 all day. This one cannot be 0. We cannot divide by 0. Send that over. X cannot equal negative 8. There's negative 8. All that is good. All that is good. Just stay away from negative 8. So that leaves us with a domain here of negative infinity to negative 8 union negative 8 to positive infinity. Let me write it down here. My 8s and my infinities, I know they look a lot alike. Start over here, negative infinity all the way up to negative 8. Close it out, get out of the pool, union it, get back in at negative 8, and go all the way out to infinity. Okay, let's do one more with some radicals. I'm going to start with a fresh piece of paper here. One more so that after Monday we're done with 2 points. Well, we've done all of 2.5, and then on 2.6 we've done 1 through 15 on your My Math Lab. Okay, let's look at f of x equals the square root of x, and g of x equals x minus 5. First thing we're looking for, and they'll prompt you for these, we're looking for f plus g. So we need square root of x, that's f, plus g, the g function. Okay, there's not much we can do with that, so that's a good answer right there. No combination of like terms. And the domain here, there's no denominator, there's no radical. Oh, there is a radical. We're going to have to worry about that. So no denominator, so we're not going to be setting anything not equal to 0. But let's do make sure that our x has to be greater than or equal to 0. There's 0. All of that is allowable. So our domain is going to be from 0 to infinity. We won't be able to include, let's say, negative 9, because that's not covered here. If you put in a negative 9 there, you're going to get an I. You're going to have a negative number under the radical, and that's just not workable. So 0 to infinity. Let's look at f minus g. Start with the f function. And then we're going to subtract whatever g is. G happens to have 2 terms, so parenthesis. Let me distribute across there, so I'm getting the square root of x minus x and then plus 5. You've got to distribute that negative over both. There's our answer right there. There's nothing worth combining. So f minus g is this. Now let's worry on a domain. We don't have a denominator, so we don't have to get picky about that. We do have something under the radical. So again, that thing that sits under the radical must be non-negative. It's got to be greater than or equal to 0. Again, we're doing the same domain. So the domain here will start at 0 and go out to infinity. for f minus g. 0 to infinity with a brace on 0 because it can equal that. Says it right there. Let's look at f times g. The square root of x times x minus 5. This will be distribution because we've got one term out in front of two terms. So for this, we get x times the square root of x. I'm going to put the x in front. That's the normal place to put something that's not under a radical. And then minus 5 on the square root of x. There's our answer. Now we have to worry about what we're allowed to put in here. Do we have a denominator? No. Do we have a radical? Yeah. Same rules. What's under the radical? The x is. It's got to be greater than or equal to 0. Any of that. Same thing. Denominator is going to start at 0 and go out to infinity. And then finally, let's do f divided by g. So let's see. Let's go grab the f. It's the square root of x. Divide it by g, which is x minus 5. That's a good answer. There's nothing more we're going to be able to do about that. But we're going to have two different things we've got to worry about in terms of domain. We have two rules. This guy is under the radical, so we know that x cannot be equal to, x has got to be greater than or equal to 0. It's under a radical, so we've got to keep him non-negative. So that's one of our things we've got to worry about. The other thing we've got to worry about is that x minus 5 is in the denominator. So we have both of our deals. We have a denominator that cannot equal 0. And we've got a radical that has got to be greater than or equal to 0. Let's move the 5 over. And let's look at what this looks like on a number line. Put 0 and 5 on there. And now first, let me use different colored pens. Makes it a little bit easier. On this one, on the numerator that was under the radical, we have to make sure we're greater than or equal to 0. So all of that is good. On this one, we cannot be a 5. We can be all of that. We can be all of that. We just can't be 5. Okay, so that sets up quite a mess for our domain. Because this is within one problem, we have to make sure that both the purple rules and the orange rules are happening in the same domain. So much as we would like to include all these bad numbers back here, we're not going to be able to because there's no orange in that. We're going to only have to be able to include the numbers that are in the overlap, where you see orange and purple. So I see orange that starts at 0 and goes out to the right forever, and that's good except for 5. I've got orange all the way there. I've got purple all the way there except for 5. So what I want to do is start at the domain equals, start at 0, getting in the pool, I get to start at 0. That's where the orange and the purple start their overlap as we come here. Only purple, only purple, only purple, only purple. Oh, right there, orange and purple. So we'll start at 0. Continuing on, oh, we're going to have to get out of the pool at 5. Then we're going to be allowed to get back in the pool at 5 and go out to infinity. And there's our answer. Really strange looking, but it combines the purple and the orange where they overlap with each other. Okay, that takes us to number 15. After that, we start with f of g and g of f, which there's no math book that will call it Fogg and Goff, but I do. We'll start on that on Wednesday, and I don't know what we'll be doing on Wednesday. I suspect we'll be doing this very same thing. These are not difficult problems. Try to keep up, and I know you have so many other things to worry about. Some of you have kids at home. Some of you don't have any kind of power, and I'm so sorry about that. Okay, I'm stop recording.